why we're doing this is because this is exactly what proofs are. They give you 2 bits of information. You need to find a third bit to prove that the things are congruent. So in this one, they gave you yn, so I'm going to color it on here, yn and qs. They also gave you py and zq. To be side, 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 you need to have 3 sides congruent, so that means that I would need np congruent to sz. Doesn't matter which way you do, you could do pn and zs, I don't care, as long as it's those 2 segments. Our next one is pyzq. So py is right here, zq is here, yn, and qs is right here. In order for it to be side, angle, side, that angle has to be included. It has to be between those 2 sides. And you can even say it while you're doing it. If this is side, this must be the included side between this one. It has to be side, angle, side. It has to be y in this case. Let's pick another angle really quick that wouldn't work. N wouldn't work because that'd be angle, side, side going counterclockwise. And if you went clockwise, it'd be angle, side, side. There's no way that's angle, side, angle. Same thing with P. If you went counterclockwise, or clockwise I should say, it'd be angle, side, angle. If you went counterclockwise, it'd still be angle, side, side. So it has to be smack dab in the middle right here. It has to be y. Just like on the bottom one, it has to be that angle that's included between the 2, which is q. So now both of them are side, angle, side, so we just have to state that. That would be angle y and angle q. Any questions on that? Questions from the homework? Yeah, sorry.
For number 2, yeah, I can't really have it.
Not at all? Okay, let's look at 2. Let's set it up, and then we'll go from there. All right, 2 says that PR bisects QPS and QRS. So I'm going to shortcut this and just say bisects given. Now, in order for an angle to be bisected, it means it cuts it into 2 congruent angles. So since PR bisects QPS and QRS, what that means is this angle is congruent to that angle, and it means QRP is congruent to RSP. Is this the right one?
Yep.
Okay. So you would state that next. Your second thing would be angle QPR is congruent to QRS. And, QPR is not congruent to that one. This should have been Q, went a little far, SPR. And then we'll also say that angle QRP is congruent to angle, SRP. And that's just our definition of angle bisectors. All right, once again, they give you 2 bits of information. You need to find a third bit. We only know angle, side, angle. So if they give you 2 angles, it has to be that included side. And that side is PR. Is there any way to show that PR is congruent to PR, Grant? The reflexive property. So my third step is to find that next bit of information, that is PR is congruent to PR. Reflexive. Now we can say our triangles are congruent. Triangle QRS is congruent to triangle SRP. It's not QRS, it should be triangle QRP. And that is just our angle side angle. Now, because the 2 triangles are congruent, you can say these are congruent by CPCTC. So that would be the 5th step. It'd be that prove, and this would just be CPCTC. Wait, other questions? Hands up.
I did number 5 a little bit differently.
Well, number 5, I actually made a mistake on it. So let's see if that mistake covers yours. And then, so there was a big mistake on number 5. And that was our step number 3 should have been, so if you're looking at mine, see how I have D as the midpoint? That should actually have been listed as given. This AD is congruent to DB should have been in this step. So how that should have actually looked is this should have been the given. Yeah. So that should have actually been the given. And we shift this down, so step 4 should have actually been that AD is congruent to a BD. And that would be a definition of midpoint. So that should have changed this a little bit. Was that where yours was different, or?
Yeah. I think
Yeah.
that's where it was different.
Okay. So yours is right, mine was wrong.
Okay.
So you're just much smarter than me. But all the other core steps were there. Other questions? Other questions? I forgot who, but other people had other questions where they're confused about something. Tori?
Number 4.
Number 4? Do you have a specific question? You didn't get past the given? Okay. Let me take a picture of it and talk about what I did. Ooh, that's upside down. There we go. All right, so number 4 gave us parallel lines. That's what I started with. I started with parallel lines. I said ZW was parallel to XY. That was given. So ZW right here is parallel to XY. And why that's important is because you have a transversal. That did not cover my line. Close enough. All right, with that transversal, actually I'm not happy with that. All right, so this line's parallel to this line. That's our transversal. Well, the reason why they gave you parallel lines is because alternate interior angles are congruent. So if we look at our alternate interior angles, that would be that angle there and that angle there, which is 4 and 3. So they gave us parallel lines just so we had 2 congruent angles. So that's why my next step was angle 4 is congruent to angle 3. I used alternate interior angles because they gave me parallel lines. If they give you parallel lines, they're looking for alternate interior angles or same side, basically. All right, so we have alternate interior angles are congruent, so they gave me that. They also gave me ZW is congruent to XY. So ZW, which is right here, is congruent to XY, which is right here. So they gave me a side angle and a side and an angle. Your job is to find that third bit of information. With side and angle, we're probably looking for another side, so we can have side, angle, side. So right now I have side, angle. I need to prove that this side, this XZ, is congruent on both of them. Well, it is because of the reflexive property. So the reflexive property gets me that side here. Now I have side, angle, side, and side, angle, side of both my triangles. Now I can say the 2 triangles are congruent by side, angle, side. Side, angle, side. Now I can say angle 2. Let me erase what I have here. I am now going to state that angle 2 and angle 1 are congruent. That's angle 1. That's angle 2. Because if that's true, then by our alternate interior angle converse, I have parallel lines. Because angle 2 encompasses this line and the transversal, and that one does that line and that transversal. All right, is that better? Okay. All right, let's go through today so we don't run out of time. All right, today we're basically doing what we did yesterday. We're doing what we did yesterday, except now we're going to include three-dimensional drawings, which don't add much to it. All we're saying is now a line can be perpendicular to a plane. But if your line is perpendicular to a plane, all the rules apply is just like two lines being perpendicular. So if two lines are perpendicular, you create 90-degree angles, correct? If I have a three-dimensional drawing, so that's a line intersecting a plane, you just have a bunch of 90 degrees. So if you ever have like a fishing tip-up thing that goes straight up, we can see that we have a 90-degree angle here. So if I have a 90-degree angle to this one here, we'd have a 90-degree angle going back here. We would have a 90-degree angle over here. And finally, we'd have a 90-degree angle right there. It creates four 90-degree angles to those things. So when I say there's a line perpendicular to a plane, you're just thinking 90 degrees, bunch of congruent angles, because they're all equal to 90 degrees. All right, that's exactly what we're going to do here. Now let me just tell you the flow of all these proofs. The given should give you 2 bits of information about your triangles. You need to find that third bit that either gives you side, 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 side angle, side, or angle, side, angle. After that, you're going to prove your triangles are congruent, and you're going to pull information from that to finish your proof. So that's how almost all of these proofs start. So we're given 2 bits of information here. It should prove that 2 angles, 2 sides, something. We have 2 bits of information that are congruent between our 2 triangles. So let's start with this first statement. M is the midpoint of AB. So let's list that first. M is the midpoint of AB. Reason I can say that? Well, they gave that to me.
Oh, I just have the next step.
Okay, what's my next step?
Is it AM equals MB?
Yeah. AM is congruent to MB. So they said M is the midpoint. Midpoint means it's smack dab in the middle of AB. So that means that AM must be congruent to MB because that's a midpoint. B is a midpoint, so those 2 sections are congruent. And that's just going to be definition of a midpoint. All right, let's list the next given. My next given is X is perpendicular to AB. We're going to do this 2 different ways. On this way, I'm going to use 90 degrees. On the next proof on the other side, I'm going to use theorem 2. So there's 2 different ways to approach this. So I'm going to approach this not knowing theorem 2. If you're not sure what theorem 2 is, go ahead and look at your sheet. Yeah.
What are the given?
I will.
Oh,
Oh, sorry.
no.
I was going to. I just didn't get to it yet. There. We're going to use that in the next proof. On this proof, we're going to pretend like I don't even know theorem 2 exists. So in that case, if X is perpendicular to AB, it creates some 90-degree angles. So if it's perpendicular, it would create a 90-degree angle at AB or AMP, and this angle also BMP would also be 90 degrees. So my step 4, if I don't use theorem 2, is to basically say, well, the measure of those 2 angles equals 90 degrees. So the measure of angle AMP equals 90 degrees. And the measure of angle, what is that, BMP equals 90 degrees. And that is just definition of perpendicular lines, or definition of perpendicular. Perpendicular means everything equals 90 degrees. Now I'm going to do one more step and say they're congruent to each other.
I shouldn't say the next step.
Oh, what's the next step?
MP equals MP.
Oh, yeah. Okay, so that's step 6,
Oh.
right?
Yes.
Yeah. And I actually use substitution on this one. All right, you were 100% correct, but let's talk about why we need to do that. All right, but you're 100% correct. That should be our next step. They gave me a side and an angle. That's my 2 bits. I need to come up with that third one. Now with a side and an angle, there's only 2 possibilities. Either it's angle, side, angle, or side, angle, side. So what I would do is on this top triangle, it could be angle, side, angle. So I'm going to ask myself, do I know anything about angle A in the given? No, I know nothing about angle A, so that's probably not a good way. So let's look at side, angle, side. Do I know anything about MP? Carly, do I know anything about MP?
They're equal.
They're equal to each other. Side. So my 6th step is just like Carly said. We're going to do MP is congruent to MP. That is our reflexive property. Cool. So now we have MP is congruent to MP. Now I have side, angle, side, which means my top triangle is congruent to my bottom triangle, but I do have to state that. So my 7th step is going to be stating that the 2 triangles are congruent. So we're going to have triangle AMP is congruent to triangle BPM. Did I write a correct congruency statement? Did I write a correct congruency statement? Spell?
No, it should be at the end.
It should be BMP. Yes, you are correct. This should be BMP. And we used side, angle, side. Now I have my top triangle is congruent to my bottom triangle. And the 2 segments I'm trying to prove, AP is in my top triangle, BP is in my bottom triangle. If the 2 triangles are congruent, then they must be congruent as well. So my 8th step is going to be AP is congruent to BP. And my 8th step is going to be CPCTC, or Kapukatika. Kapukatika. Hey guys, it's kind of a long proof, right? We have 8 steps. But I just want to point something out to you. That's all the given. All of this was just the given and explaining what the given means. That was the first 5 steps. The only work we had to do was saying MP is congruent to MP, saying the 2 triangles are congruent, and then pulling that out. Carly.
If we skip like any of that on a test, we could take off.
Any of the given stuff? What do you mean by skip it?
Like, I mean, like, we didn't, like, explain, like, AMP equals BMP or something like that.
You could lose points, depending how critical it is. And what I'm looking to is, did you draw it? Or did you explain something down here or something? Okay. There is a way to shorten this. You can actually shorten these 2 steps, and that's what we'll do on our 3rd proof. Not that one, actually. These can be shortened using Theorem 2, and we'll talk about that in a second. So the Theorem 2 lets us jump straight to this statement. Hamza.
Why do you need to state that AMP is congruent to BMP? Because, like, they're both 90 degrees.
Oh, here?
Yeah.
Like I said, you have to state it in this fashion if you use Theorem 2. So look at Theorem 2. Theorem 2 lets you skip all of this and jump straight to step 5. You don't have to have step 4.
Okay.
Yeah.
Could you also use the perpendicular bisector?
It's kind of a stretch because I didn't say it's a perpendicular bisector.
Okay.
Theorem 2 is the one you want to use to skip any steps. Theorem 2 specifically says if you have perpendicular lines, then your 2 angles are congruent. Theorem 2 would be the one to skip that. And we'll do that on the 3rd proof today. All right, let's go to this next proof. We did this proof in class yesterday. You did this proof as homework last night. You're going to do it again. you are, without looking at any of your notes, you can use. So the first thing I'm going to look at is the given. They always give me 2 bits of information of the triangle. So my step 1 is WX is congruent to YZ. I'm going to color it in right away. I've noticed walking around, a lot of people didn't even write this, and that's why they got stuck. WX is congruent to YZ. And the second bit of information they gave me was ZW is congruent to XY. ZW and XY are congruent. And that is my given. All right, just a reminder, we need to prove that WX is congruent to ZY. WX and ZY. So what I want to show is that angle 1 and angle 2 are congruent, because then I can use that alternate interior angle converse. So I need to get to angle 1 and 2 being congruent. Well, right now, do I have parallel lines? No. So you shouldn't be, and that's the other mistake I've seen across the board, is people saying 1 and 2 are congruent because of alternate interior angles. You can't use alternate interior angles unless the given is you have parallel lines. So in this case, we don't. And since we don't have parallel lines, I need to prove that this triangle is congruent to that triangle. They gave me 2 sides. That means either I find the included angle or the third side. Well, the easier of the two is going to be that third side, saying that ZX is congruent to ZX by the reflexive property. Boom, boom, boom. Now I have side, 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 so your third step is to show that you have congruent triangles. So I have triangle, let's call it YXZ, is congruent to triangle WZX. And that would be side, side, side. This triangle is congruent to that triangle, so every part here is congruent to every part here. So my fourth step is going to say that angle 1 is congruent to angle 2. My fourth step is because of CP, CT, C. And one quick reason why we needed to do that, let's color in the 2 lines I want parallel. I want ZY parallel to WX. So if I color in my transversal right here, I am trying to show that angle 1 and 2 are congruent because they're alternate interior angles. I did it. So now we can say that they are parallel. Step 5 is WX is parallel to ZY, and that is alternate interior angles converse. Once again, if you couldn't do that in that speed of fashion, you need to come and get help and practice these. Or just go home and just try them over and over and over until you get the hang of it. All right, so that is that one. Now we just have one more proof. Any questions on any step that I did here? This followed every single proof that you get. They give you 2 bits of information about a triangle. You need to come up with a third one, and then use that to finish your proof. That's how all of these work. All right, our next proof. We have PO is perpendicular to plane X. So I'm going to start with that statement. PO is perpendicular to X. That is given. I'm going to, in step 2, everyone take out your pink sheets and look at theorem 2. Take out your pink sheets and look at theorem 2. Theorem 2 says that if you have perpendicular lines, all of your angles are congruent. That applies to perpendicular lines to planes as well. So if I say PO is perpendicular to X, look at PO, it runs down here. It creates 2 angles. It creates POB and POA. And perpendicular creates 90 degrees, so that one's 90 degrees. This one's 90 degrees. But theorem 2 lets me say that angle POB is congruent to angle POA. And that's going to be by theorem 2. That is in place of that purple stuff. So in this method, I used 2 steps because I didn't use theorem 2. And this one, I used theorem 2. It cuts those 2 steps down to just 1. Either way is fine. Either way is worth the same amount of credit. All right, so now we have POB is congruent to POA. They should give me a second bit of information. They gave me AO is congruent to BO. Let's draw that on the picture, AO and BO. They gave me a side and an angle. And before Carly yells at me, I got to write down this given. All right. I have a side and an angle. You have 3 theorems. You have side, 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 and angle, side, angle. Well, we're not going to do side, side, side because they gave me an angle. So it's either angle, side, or it's side, angle, side. If it were angle, side, angle, you'd have to find B and A. Do they talk about B and A in the given at all? Angles B and A in the given at all? No. So that's probably not the best one. So then let's look at side, angle, side. In order for side, angle, side to work, we'd have to have PO equaling PO. Does that work? Yeah. We would just use the reflexive property. So that would be my step 4. My step 4 would be PO is congruent to PO. That is my reflexive property. So once again, this was all given. That was all given to me. All I had to do is find a missing side or an angle to complete either side, angle, side, 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 or angle, side, angle. In this case, we're looking for side, angle, side. So let's draw that on there. So on my PO, I put my 2 dashes so I can see I have side, angle, side. Now we just have to name the 2 triangles that are congruent. I'll have triangle POA is congruent to triangle POB. And that is side, angle, side. I just need to show that PA is congruent to PB. Well, PA is part of one of those triangles. PB is part of the other triangle. Corresponding parts of congruent triangles are congruent. So we can go right to our final answer. Our 6 is PB. That says B. PB is congruent to PA. And that is just Kapukatika. CPCTC. I just want you to look. 3 steps were given. 1 step I had to do work, and then I just had to interpret what that means. Most of these just imply that you have to do 1 big step that's not included, and you have to use reflexive vertical angles or something of those sorts. Yes, Sam?
So you can put AO and PO together in the first one there with the given.
Oh, could I have listed it in the first given? So could I move 3 up here?
Yeah.
Yeah, you could.
Okay.
So what Sam's asking is, can you just take, maybe I should do it in red. He's saying, can I just exclude kind of writing step 3 and just take that information and put it right there? Like with a comma? Yes, you can. The reason I want to list something and say why it's important. And then list the next thing, say it's why it's important if I have to. All right, I like to keep that order because it keeps everything kind of structured and I don't forget about stuff.